Hello all. Uh, a very good day from my side. Today we are going to discuss. We are going to discuss about the VGA text mode. So this would be our third video in this playlist about writing an operating system in Rust. Till now we have discussed about the freestanding Rust binary and creating a very minimal Rust kernel which just prints an hello world onto your screen. Today we are going to add some more functionality to our operating system, which will write any custom string which is given which is given to the function. It will print that custom string um, on the screen. So for that. I would like to keep this video short because it is just adding some more functionality to the println macros. Basically, we are creating our own print line macro in this particular video, and for that, what all things will be needed that we are going to discuss. But for the information, I have committed the code which we have written till now to this particular repository. I'll mention the link in the description as well. So let's go to the code and let's open our blog. So what is a VGA text buffer? In the last video we have discussed that in order to print in order to print anything on the screen, we are using the text buffer, and this text buffer is nothing but it is a 2D array which is basically of 25 rows and 80 columns, and we are utilizing this particular 2D array to write our message on the screen. And how are we writing that message? With some color coding and some background light as well. So with a specific color code and with specific background color, we can highlight our text. So how to handle all these things? In order to handle all these things, we have will create a module that is VGA buffer in our code, and everything related to the printing functionality will be handled in this particular module. So without wasting any time, let's get started. Let's get started with the code. So I have already written some basic code of printing, because this code was nothing but about it was adding some functionality to print the characters on the string. So let's go step by step into that. So first of all, the author has defined enum of colors. So as you have noticed that this is a specification of the colors which we can use. So starting from 0 to I think F, we have different set of colors. So all these enums are defined in this particular enum, and we have derived let me increase the font size a little bit over here. I think, yeah, this is enough. So we have derived a debug trait, clone, copy, and partial equal. So in order to just specify, debug is for printing. Now these are the derived traits which we can derive on our custom types, and each derived trait can be used for different functionalities. For example, if you want to print our structures, then we need the debug trait. If you want to send our struct from if you want to pass the ownership of our struct to some other function, then we need clone and copy. If we want to do comparison of our struct, of the data type of our struct, between the data types of our struct, then we need partial equal and equal trait. So we have derived all these traits for our custom struct, and then what we have defined is we have defined a color code struct which has nothing but which is a wrapper for U8, which consists of only a U8 byte. And then in this color code, basically what we are doing is we are implementing this color code. We are implementing functions for this color code structure. So if you have noticed, we first of all we have defined the color enum, then we have defined our structure which is going to maintain the information about the color code. So what we have implemented here is a new function, and it takes two arguments, that is color of type color, that is foreground and background color. And if you see, this color code is of 8 bytes or 8 bits, I would say. and the first 4 bits talks about the background color, and the last 4 bit talks about the foreground color. So what we have done is we have created a color code struct. The background bits are being what we say left shifted by 4, and the foreground bits are kept as it is. So in this way our color code structure of 8 bits will consider the information about our background color and our foreground color. In this way we have created our color code struct. Then the author talks about creating the text buffer. So now text buffer consists of an ASCII character and a color code. So what is the ASCII character you want to print on a text buffer, and what should be the color code for that, for the background color and the foreground color? So for that, very simple, we have created one struct, screen character, and again we have derived all the required traits that we may require in the future for that particular struct. The representation repr C tells the compiler that it should be a C type structure. So in this particular struct, we have an ASCII character of 8 bits and a color code which is of type color code. Then we create our buffer. So buffer constant are height and width, as we have discussed in this particular table we have seen, and also it's mentioned somewhere here that it is of 25 rows and 80 columns. So that are the two constants which we have used. Let's say buffer height is 25, buffer width is 80, and then buffer would be a character buffer of screen char is a struct of buffer width, and it would be a two-dimensional array of buffer height. So let's, for the time being, just ignore this volatile. We'll discuss what volatile is down the line, but for now um, just imagine this buffer as a two-dimensional array of characters. Now this character is nothing but a type of screen character which is of buffer width, and each buffer width into buffer height. So this would be our VGA text buffer ready, with in which every display character is a screen char, and screen char is an ASCII character plus the color code. So this is how we have created our buffer. Now we need to create functionality for this buffer. In we want to write something on this buffer. So for that we have created writer struct. Writer struct takes column position, color code, and buffer, and then we implement writer. So let's go back to the blog once. So we have discussed till this particular point. Writer will always write to the last line and shift the lines up when the line is full. So that's how we are planning to create our writer. And then in order to print something, we implement write byte method and new line method, and what else we are implementing? Clear row and write string method. So these are the 4 methods for our writer struct. Now, if you see closely here, our writer struct has the types of column position, that is a U size. Color code is of type color code, that is the struct which we have created in the beginning, and this buffer is of type buffer, which we have created over here. But there is this a reference static mute in front of this buffer. So what is this reference static mute? I would like to spend some time on this, because this is where our embedded systems things or embedded system concepts comes into the picture. So when we say anything, if we go back to our embedded systems or our C language, when we say static, so static keyword is generally associated when we want to specify a variable's visibility to that particular file only. And here this static the keyword static is being used in reference, or it is used with a lifetime. So when we say if you look closely, it is we are defining a lifetime of this particular buffer as a static lifetime. So what we want to say that this buffer will stay until the program execution, or until the program executes. So this the lifetime of this buffer is throughout the execution of the program. It is not like if we have passed this structure to or if we have passed this buffer to some function, and then function execution completes, and then that stack unwinds, so this buffer will also go. But it's not like that. This buffer will stay until the program is in the execution mode, and this will be allocated a global space. So let's see what they have used for time for, and what the author wants to say. Note that we need an explicit lifetime here to tell the compiler how long the reference is valid. The static lifetime specify that reference is valid for the whole program runtime, which is true for the VGA text buffer. Makes sense, right? Until and unless our OS is in the execution, our VGA text buffer lives, and so does the buffer as well. And now in order to write, simply we need to add our write byte functionality. So what are we doing over here? If we are matching on the byte, whatever byte we have passed, if it is a new line, then we are calling a new line function. If it is not a new line, then uit. So what are we doing? We are first checking if the column position is correct. If the column position is greater than the width, then we are just skipping, we are just calling the new line function. Then we are calculating the rows and the columns in the color code from the details what we have known. And then finally we are writing that particular screen char onto that particular row and column, and by after that we are incrementing the column position by 1. So this was a very simple right thing, but if you look at this carefully, here these guys have not used the volatile functionality, so that's why they are directly assigning a screen char. But in our case, what I am doing is I am using dot write function on this particular buffer, because I have declared them as volatile. Now why volatile? Again, let's scroll down. We will try that out at the end. Yeah, so here we are talking about volatile. So again, coming back to our embedded C thing, volatile is nothing but when we want to avoid any optimizations by the OS. Now here question might arise that we ourselves writing our OS, but still compiler does some optimizations. So that's why in order to avoid those optimizations, we need to use volatile. And even if we go even if you want to go more deep into this volatile, when we declare anything as a volatile, that means we are telling that compiler that this particular memory location can be updated by any external entity as well. For example, it can be updated by memory mapped IOs, it can be updated by some interrupt subroutines, or this particular memory is is the memory which is mapped with an IO, like we have talked in the case of memory mapped IO as well. For example, let's say that this particular this VGA buffer, it is basically a memory mapped IO. We are writing something onto that buffer, which in turn prints onto the screen for us. So that's why we need to make it volatile, so that every time when we access this particular memory, the compiler will go onto that particular memory location, check what is there, and then execute our instruction, or write to that particular memory location, or read from that particular memory location. So in this way we can avoid the unnecessary compiler optimizations. So this is a very important concept in the embedded systems space as well. So in C we can directly use volatile keyword and declare any particular memory or any particular variable as volatile. But in Rust we need to use a volatile crate with specific so for this block they are mentioning that we need to use a specific version only for the compatibility issue. But if you want, if we are developing the latest software, we can use the latest version also. But for the sake of simplicity, I have used the same version which is being mentioned over here. So what volatile says, is that when we use volatile crate, we can bring into the context using by the use of use keyword, and then we can wrap our structure or wrap our variable inside this particular volatile struct, and then it will be treated as a volatile variable in the case of similar in the case of C. So the same thing I have done here as well. I have used the volatile keyword, and here while declaring our buffer, I have wrapped our screen current into the volatile. So every character is a volatile character in our text buffer. Then formatting macros. So we all know that in order to write our println macro, we need to implement this format macro so that we can write our println macro as well. So we have implemented the format macro also. So we have implemented write for writer. So this is write is a nothing, it's a trait which we have implemented, and if you go inside this trait, it will consist of write str function and write char function. What else it has? Write format function, and that's all. In a function writer struct, str does the reference, it just takes the string and calls the write string method on our struct. Then now we can use rust built-in write macro or write ln macro for our use cases. So let's try this out. I have already built so here what they are saying is we can use our write macro. So here is the example of the write macro which we have used. Previously we used to write it like this. We have to write it like this: writer dot write string, and here I have to write string from write function. But then after implementing the write macro, we can just write line macro as well, where we can provide the writer struct or the writer instance, and then provide this is the from macro. So we are getting so in this way we can use the macros once we implement them. So let's try to build it. What we are going to do is first of check cargo build if it is building. Okay, yeah, it's building. Let me attach my power cable also to make sure my yeah, okay. I think now it would be smooth. Let's clear the string. So we all know in order to build the boot image, we need to do cargo boot image, and it's built. Now in order to test this thing, we can go over here and we execute this command qemu systems and we pass our boot image, which was the latest boot image, and it should, yeah, hello string from write function. This is the line from macro. The numbers are 40 and 0.33. So write strings write in the same in the same line, and then write ln writes the line with the new line character at the end. So let's close this thing. And let's proceed. So now, what the author is talking about. So this is this until this point, it is all okay. But now we want to make this writer struct available for our other files also, because this file VGA text buffer which we are creating, it is not meant for usage in the main file only. It is meant for usage in different OS modules as well. So for that we need this writer struct to be a global variable. So for that what we will do is we are going to declare it as a public static writer struct over here, and it would then it would be accessible to any of the models which we are going to write in the future. But now the problem is the Rust borrow checker and the Rust ownership rules that comes into the picture, and they says that you cannot pass multiple mutable references of a static variable or of a global variable to different functions. So for that case, what we need to do is we want to use static initialization. That is what we are going to do is will initialize it once and then use its mutable reference for different functions whenever required. So now in Rust we have a very interesting thing for such kind of scenario. We have reference count, that is RC, and we have ARC, atomic reference count. So if I go here, I just say ref cell and Rust in Rust. So let's go to ref cell, what they want to say over here. I'll not will not go very deep into it. um, mm, a mutable memory location with dynamically checked borrow rules. So what this they want to say, they are not going to check the borrow rules at compile time, but they are going to check the borrow rules at runtime. So in this case we can what we can do is we can do interior mutability. But even that is a later part. In order to get to that particular point, we have to first initialize our struct. So for that we are using lazy static, and this is how we are going to import the dependency lazy static with version 1. And then we are initializing our struct globally with this particular code. So let's use this code and go to our VGA buffer. So here it will be initialized as a pub static. Okay, so let's put this thing at the top, the imports. Then we have our enum. So enum, what happened? Enums are okay. Then we have our writer struct, which is a public static reference of the writer, and we have initialized that only. So that is the advantage of using lazy static. And also we need to import, we need to add the dependency into our cargo.toml as well. So here we'll say lazy static, static static is equal to version 2.0. Yeah, we can import. Okay, we need to import the features as spin no standard as well. What is this spin lock? We will talk about that. So first of all, let me just import this version is equals to 1.0 and features is equals to this thing, spin lock. Okay, this makes sense. Then spin lock. So as the author is saying that we need to get synchronized interior mutability. That means even with the reference count thing, for example, for the time being, our OS is a single threaded operating system till now. We are just executing from the main, then we are calling the hello world functionality, and we are extending like hello world function. But down the line there will be different modules, there will be different threads which we are going to spawn, and then different threads will be calling different the printing functionality from their respective thread stack. So in that case, in order to make sure synchronization between this thread and between this global variable or this global writer instance, we need to make sure that there is only one and only one mutable reference, or there is only one and only one thread which is able to access mutably our writer struct. So in order to do that, what thing we can use? We can use mutexes. If we go back to our embedded C days, we use mutexes or mutex lock for any for synchronization between the threads. So here also we are going to use the same thing. um, so mutexes are provided by spin locks, and also the spin locks, we need to use the mutexes for the core library, not the standard library. So for that we need to import this dependency, that is spin lock. So we'll do that, and then we can add them into the file like this. So we will add them. So now we have mutex also. Why is this giving an error? Lazy static unresolved import. Go to cargo.normal. Okay, let's define it in the same way how these guys have defined. So if we copy this, and then if I paste it over here, lazy static, and then yeah, this goes off, and then this is about the unused thing. So we're going to use it, don't worry. Then we have spin logs. So here now our writer is of type mutex. It is wrapped inside a mutex. So I will just use this code, or we will just wrap it inside. Where is our static? So it would be a mutex wrapped code. Control X and Control V. And in order to do that, we need to wrap it also inside the mutex new thing. So this will be a writer, and finally here the mutex will get closed. Yeah. Then in order to call them from the main function or our start function, this is how we are going to call it. So what we are going to do is we are going to bring the write trait into the picture. Then we are going to use VGA buffer write lock. Now this writer is a global static thing, that's why it is in the caps lock, that's why it is in the caps. And then you have to call the lock method in order to make sure that this particular function is only and the only one which is having the mutable access to our global variable. So let's say let's go to our main function and then use it from there. So this is our start function. This was the old code. We will remove this thing, and we need to first of all use core format write. This is okay. Then we need to use VGA buff dot writer writer dot lock. So this is a VGA buffer writer lock dot. Now once we get the lock, we can access this particular methods from our from our struct. So we will be using write string, and the string is again, let's say test the synchronization test synchronization. And even before that, I would like to write one more thing. Hello from VGA. I want to write hello from rustOS. This would be the default string I would like to stay on top. And then we are going. We have also used a write macro. In this way, we can use a write macro. Let's forget about that. And now. Uh, here the author is talking about the safety as well. So until now, we have got rid of our unsafe block, and we have only one unsafe block, which is needed when we are creating buffer for this particular pointer. Now this is a raw pointer, that's why we need an unsafe block. So that was about the safety. Now finally about the println macro, how to create a println macro of our own. Let's dive into that. But do we want to test this before that? Yes, we want to test. So we will do cargo build. So I think it is build. I'll just make it once again. Yeah, it's build. And now we are going to create the boot image. So that is cargo boot image. So our boot image is also ready. Here we're going to run the boot image, and this is what we have got. Hello from rustOS. Test the synchronization. Okay. So there is no new line after this. In order to add that new line, we need to use write ln thing. So okay, let's do that in the println macro itself. So we all know that in our standard library we have print line and print macro, which takes care of our printing stuffs. Like in the same way we have the things like in the C we have printf. Now these are all defined in the standard library. So now for our operating system we need to define it for ourselves. So how to do that? We need to use the macro syntax. So what this macro syntax is, let's dive into that. And this we are going to add it in the VGA buffer only. So this is how we are going to export a macro. So whenever we are going to write a macro, so we will be using a macro rules string, and then in front of that we need to define our macro which we want to create. And in that particular thing, if it is an empty thing, then we are just what are we doing? We are just printing a new line. But if it has an attribute, then these are the argument which is going to catch that particular arguments. And these arguments will be replaced by whatever we are going to pass inside this println macro. So if we say here, if we say println hello world, any string inside this, so this particular string will be an argument for this print macro, and that argument will be cached here, and that argument will be replaced by this arg, and so we will get what we will get in the end. We will get a print line with the arguments which is being formatted over here, and then after that a new line. So this is how I think this is a very simple example of println macro or the rust macros, how to use. Here also he has defined in a very simple words. Println macro has two rules. First rule of the invocation is without argument, which extends to which just extends to the new line. And then next is with argument. So in the case of with argument, we are adding the functionality over here. And the print macro, so here then the question is, where is this print macro defined? So this we also need to define this print macro, and that we will define it over here. We'll define it just above it. So what print macro says, it will always be called with the arguments, and whatever are the arguments, We are going to pass it to car crates IO and print with format arguments. So this is how we have created our print macros. Now, this particular create IO to print is not available for us. So we already have our VGA buffer for us. So we are going to replace this with our VGA buffer methods. So what are we using? We are using underscore print, and we need to define this print function somewhere. Okay. So this would be the actual code. Let's copy that full code and let's paste it over here. So here what we have done, we have defined a print macro, we have defined a println macro, and finally we have defined a hidden function which is not open to the user underscore print, and that print function takes an argument and some format arguments. So let's quick fix this. Import, yes, import, yes, import, and that's how this, I think. And now we can directly use our println macro from our start function. So let's go back and let's get rid of everything from the main function. Oh, acha, I think we have added in the wrong place. This is the main function. We will just cut this and we will add everything in the VGA buffer, so that all the things related to the print things will be in the VGA buffer. Yeah, this is fixed. And from the main.rs we are just going to call now println, that is hello world from rustOS. This is our first line, and then println test synchronization and macro, and then unending loop. So let's build this. It's build, and let's create the boot image also. Cargo boot image. Boot image is also created. Let's test it quickly. Yes, we have got it working. So now everything is clean. We are able to print the strings using the println macro, very similar to what we used to do with a standard library. So this would be our first step, where we have created our own macro for our operating system, and we can use that macro in the very similar way, the way which we are using in the standard library. So now they are also printing the panic messages. In the panic handler. Yes, we can use the macro in the panic handler also. So here we can print ln panic occurred. We can build this, and yes, this also builds successfully. Oh, they are printing actually the info over here. Panic occurred because of an argument info underscore info. Okay, I think this will also build without any error, and we need to do cargo boot image. This is also done. Let's try to let's clean this thing and again execute it. Yeah, it still works without any problem. And yeah, that's all for this video. In summary, we started with creating our VGA buffer, then we went on writing our own struct. We added a functionality to write a string, write a character, adding a new string for the struct, And then what we did is we made our struct as a global variable, so that that struct will be available to all the modules for our operating system. And in order to make that global variable, we need to add interior mutability thing, that is we need to take care of synchronization. So for that synchronization, we have used mutexes from spinlock. And once we use mutexes, we can make sure that any module which is using our global buffer will make sure that it has its that particular module is the only one which is having the mutable access to the buffer. So I'll push this code into the repository which is mentioned. And so that's all from my side. In the next video, we will directly jump on to the interesting things. For example, I would like to go into CPU exceptions. What are CPU exceptions? And then we are going to dive into more interesting things like double faults and hardware interrupts and all. So thanks for watching, and